Alright, so this is the question. So unfortunately, I had a bit too much time when I was putting up the questions. I just couldn't help but solve it. So we don't quite have a good live solve experience here, but question goes like this. You have an isosceles trapezium with 500, 650, 333, 333. Yeah. So of course, the 333 could even go in like this, but that wouldn't be an isosceles trapezium. So the isosceles refers to these, I guess, angles as equal. And the question asks you if you take the angle bisectors, okay, and you meet them, you get P and Q, right? What is the length of PQ? Oh,
Close man.
interesting.
Did I just open it?
Let's press the key, yeah.
Okay.
Yeah, you'll just leave it outside. Don't worry about it.
Close man.
Yes, it's less than 500. Yeah, so this style test is the same as the AIME.
Less than 419.
So you have 1,000 possibilities, and if it's less than 500, you already got rid of half of them. Yeah.
Less than. I'll cut out one more.
Really? I didn't know that.
Probably. If you drew it to scale, it would not.
Okay. Did anyone get any progress on this question?
That those two triangles are right angled.
Oh, okay.
Same.
Very good. So Rhianna got these two triangles are right angled, yeah?
Yeah. And then they're also congruent.
Yes. They are.
And then you have two isosceles trapeziums.
Mm-hmm. Okay, so I guess there's one observation that you don't really know how useful it is until you're missing it. But this is the very first thing I saw, and I couldn't solve the problem with just it by itself. But I think it's a good lesson for geometry. Okay, so I claim that PQ, this line PQ, right, is parallel to the top two lines. Yeah. And it's exactly halfway in between.
Okay.
What, do people agree with me on this one?
Halfway.
Yeah.
I guess in the diagram it doesn't look like it because there's 2 grid squares below and there's 2.5 above. Not really, yes. No. Okay, let me tell you my reasoning then, okay?
Okay.
So, wonder if you even need it, but okay, so the angle bisector, okay? I don't know if you watched the video on angle bisectors and incircles. You remember this? Is basically, so if you have two lines, right? And you have an angle bisector, yeah? So the angle bisector is exactly all the points which are equidistant from both lines. Yeah? It's halfway in between, right?
Oh.
Okay. So if you get this point Q, it's equidistant from those two lines, right? But it's also equidistant from these two lines, yeah? So therefore it's equidistant from the top two lines, the horizontal lines, yeah? So this observation about angle bisectors is I don't know, it makes you feel good about the question, even if you don't necessarily solve it from there. It makes you feel like you understand what angle bisectors are. Okay. So if you know that, what could you do?
You could find the the height.
Yes. You could find the height.
But I don't see.
Need is a funny thing. Okay, how can we find the height?
Pythagoras.
Yes.
But I don't have a calculator.
Oh, you don't need a calculator. Just try to delay the calculations until as long as possible, okay? So if you want to find the height, oh crap. This is like h, right? Yeah. So can you see its hypotenuse is 333, and the difference between 550 and 60, 50 is 75 on each side, yeah?
Mm-hmm.
So h squared equals 333 squared minus 75 squared, right? And if you were going to do the calculation, I think you would delay it as long as possible, but you would do 333 minus 75, and just keep it like this, 333 plus 75, yeah? Okay, but you don't want to do any calculations that you don't have to, right? Because in the end, you might just need like h squared over 333 plus 75 or something, right? Then why would you even add those things up? We just cancel out, right? All right. Okay, so does anyone have an approach to solve the problem from here? You don't have to actually be able to carry it out. We can carry it out together. But do you have any approaches?
Look at the area.
The area.
I don't know.
Oh yeah. Oh wait. The area. Oh.
Because you can get to the area.
Oh. Okay, let's look at your area approach. How do you do this?
I don't know.
Area of the
You
whole
get-
thing?
You get the height, right?
Yeah.
And then get that X in the middle and the two triangles on the side. And that's one way to get the area. And then you get like that formation to get the area.
Oh, I feel like this is better than the idea I had. Alright, let's explore this idea. Okay. Everyone understand what the idea is?
No.
So you just calculate the area of the blue trapezium.
Yeah.
Okay. So the area of the blue trapezium. So the area, the blue area is, what's the area?
Height times
500 plus 650.
wait, height over 2 minus
Yeah, so it's h over 2, 500 plus 650. Yeah? And we know all the value. We know h, so we know what that is, right?
Mm-hmm.
Okay, what's another way to get the area? Let's put this one in red.
shapes.
The shapes, yeah.
500 times h times
This is brilliant.
75.
Okay, so which area do you want to add up first?
500.
500
H.
plus PQ, right?
Yeah.
This is H on 4.
Yep.
Yeah? What else?
Then the other trapezium.
So that's also H on 4, yeah?
So
This is brilliant.
this video is sponsored by Brilliant.org.
It's more like brilliant is sponsored by me. Yeah, actually I've got a few brilliant accounts if people are still interested. Yeah. It seems like. Oh, did it? Oh, he should have said something. Maybe it's because.
Why is there another middle side?
It is the same one. I think maybe he just didn't finish it. It had a lot of water with him.
Oh,
Oh, okay. I can't remember that you did, but maybe you can do it again and I'll try to address this. Okay.
Nice.
Pass with 2 yes.
Alright, and what are the areas of the triangles?
H times 75.
Times 75. Which triangles are we doing here?
The two sides of it.
So it's like B,
Those side triangles.
like BCQ, yeah. They're congruent as you said, so they're the
Oh.
same area, yeah.
Times QC.
I feel like this puts my solution to shame. This is
What did you do?
oh, I just Pythagoras bashed everything.
I thought area was the way, and then I gave up doing it.
Area is the way to go. It is definitely the way to go. Even if I can't see how to do it from here, I know it's the one. It just feels right. Okay, what are the area of the triangles? So this is the question I thought of immediately when you thought of the area. When I could solve this question, I realized this is the way to go. I mean, obviously, there's lots of ways to go, but feels the nicest.
Do we need to get the this will be QC. We're going into like Pythagoras with the
What's the area of the triangle, people? That is the magic question, isn't it? That is the question I immediately thought of when you said areas. I don't want to spoil this until I've given you a chance to figure this one out. What is the areas of BQC?
Because of this, I have to be spelled on hard.
It's not quite like this because it won't. You don't quite know where Q is, right? You don't know where Q is horizontally. Alright, I'll give you 3 more minutes for this. 2 more minutes, 2 more minutes.
Does it look so like that?
It relates to stuff I've said already, so it's just kind of how close attention you're paying. It doesn't count the seconds.
Is BQ just H over 2?
BQ?
Yeah,
What BQ?
the line.
Because Q to the line is at H over 2, right? Alright,
Wait, sir.
yes.
What's the thing with exterior sum of triangle angles from what?
Exterior sum. What do you
Yeah, I
mean?
just searched up keywords. What's it? What's the rule?
Exterior angle sum is like 360 for like basically all polygons.
You know, like in a triangle, exterior angle.
Oh, is equal to the interior.
Oh,
Opposite angles.
interior.
Okay, so I don't know. So the reason, okay, so this thing is kind of it's done to death in primary school maths competitions, okay? But it still makes a reappearance in high school, especially in Australia because we don't learn any people don't learn anything, so they don't assume you know anything. So the main thing about areas, yeah, what's the area of a triangle? Yeah, what's like
Speed.
it's half base times height, right? So in this case, we got two triangles, so it's just base times height, yeah? Okay, so I guess you have a clever choice of base and height. Um, so we don't want to make the cube be the base or the height, yeah? Because we don't really know where Q is, yeah? But could you imagine making BC the base?
Oh.
So if you make BC the base, then what's the height?
H over 2B.
H over 2, yeah? Because
Oh.
Q is equidistant from all three lines, right?
Oh.
Oh, yeah.
Isn't that crazy?
Nah.
Now I feel dumb.
That's not fair.
So you notice that the okay, I wouldn't even tell you what to notice, but it's a brilliant question. Only doing it this way would you think it's brilliant. If you did Pythagoras, you'd be like, oh, why? Am I just a glutton for punishment?
Sir,
Yes.
I had another idea, but I don't know if it works now.
Oh yeah, what?
Like, so since the PQ and like the top line like go parallel, so
Yeah.
that's like co-interior, and then I try to find like the angles in the QBC, and then like
Mhm.
using ratios to find what QB is to 3, QC is 3.
Possibly.
Because it's just 30, 60, 90 triangle, and then that's
Is it a 30, 60, 90 triangle?
yeah, that's what I thought, and then
I don't think so.
I thought it was. And I was just trying to find out.
No, it's unlikely. Yeah, so I'll outline some other ways to approach it that aren't as nice, but I think people shouldn't only go for the nice way because the nice way sometimes, sometimes there's for whatever reason you're not attuned to the nice way, right? So sometimes you're just kind of sort of fighting with bare hands, you know what I mean? But everyone needs to be able to do all the different ways of surviving. Okay. All right, what do we do from here? Someone finish it off.
Back the add the 500 years.
Yeah. Yeah, so no, I've already added the two triangles because I just instead of doing half base times height, I just did base times height, you know?
You make it one equation.
The height just happens to be h over 2. Make it over one equation, yeah? So what do I write?
H over 2 in brackets 115 over. Okay. Take it forward.
Cows are in the rain. Just sitting there.
That'll be fine.
H over 2, 3, 3, 3, 3, yeah? Okay. I mean, what's the first thing you notice about this equation, this expression?
Try to take out the
The h is a factor of both sides, right? So you could literally just cancel all the h's, yeah? So that's an equal sign. So you're confident you can solve the problem here, right? Because you have one unknown, and that's the question asking you. That's what the question's asking for, right? The h was the only other thing, but you knew that anyway, right? But it just basically turns out you didn't even have to know what the h was, which is again quite amazing. Yeah, you do a lot of things here. Yeah, I guess I'm never really tempted to add the 500 to the 650 for some reason. I'm more tempted to subtract stuff. I don't know, what do people do? Maybe you can try to finish this off yourselves. But for some reason, I'm tempted to do stupid stuff like this, like quarter 500 plus 650, and I cancel out these two things. So I get half PQ plus half 333. I don't know what I'm doing. Half 250 plus 325 equals half PQ plus half 333. Okay, let's check back when we all have the answer, okay?
I think it's working out.
250 plus 325 PQ plus 333. Therefore, PQ equals, let's see, we'll just get 242.
Yes, same.
What you get?
Yay.
Yeah, so I sort of cancelled the 325 with the 333 there.
I just multiplied with some of the so I just
Hold on, I'm not getting this.
I think I know
Doing the too challenging way.
why.
I think I got it. What did you get? What was the answer? Where? What?
Yeah, so that was quite satisfying, don't you think?
I didn't get that.
So you may be like, oh, I never see that in the exam, but here are some other approaches that you can see in the exam.
Contributed.
Like, it was a brilliant idea.
I didn't get it.
Yeah, so whatever you do, don't have a fixed image of yourself, you understand? Have a maybe ideal image of what you want to be, and then you can even be greater than that. Okay, so we have some other ideas that'd be interesting to explore that have not been explored. So, though I've kind of got ingrained in my head these are H on 2s and this is 90 degrees, so they all involve that. Okay. Actually, one that might not even involve this is 90 degrees, but so for example, you could do like kind of like this. You can make this like a Y and this like an X, right? And then you get a bunch of Pythagoras. So you can make this like an A and this is a B, right? So this is what I did before. So you have 333 squared equals A squared plus B squared, right?
Yeah.
But A squared equals X squared plus H on 2 all squared, right? Same with B squared. And so you get an equation that's 333 squared equals like X squared plus Y squared plus something you know, right? And then, but what is X squared? What's the relation between X and Y? Well, obviously, for example, 500 minus 2X is equal to 650 minus 2Y is equal to PQ, right? So then you just have one variable and it's like a quadratic, right? And so you could find X. And once you find X, you get PQ. You know? That's kind of like the plan for Pythagoras bash. Another idea which involves trig is if this is like theta and this is theta, right? You have that So this is like 75 here. You have tan 2 theta equals h on 75, right? And then you have sort of tan theta equals h on 2 on y. And tan 2 theta, you know, is tan squared theta on 1 minus tan squared theta.
So what is tan?
Now tan is opposite over adjacent.
Opposite.
Opposite side of it.
So if you have a right angle triangle, tan of this angle is this side over this side.
So we divided?
Yeah.
Oh.
So there's a formula for this, and if you write this equals h on 75, then what you have, sorry, it's not tan squared, it's 2 tan theta, yeah, on 1 minus tan squared theta. So what you get when you cross multiply everything, you know what h is, right? So you get a quadratic in tan theta, yeah? So in principle, you can figure out what tan theta is, yeah? And if you can figure out what tan theta is, you can figure out what y is, yeah? And if you can figure out what y is, you can figure out pq is, yeah? So you can see these solutions are all beneath your solution, which is quite elegant.
It's a bit easy way.
Yes. So the solution that requires the least thought usually is the longest, right? Sometimes that's a good thing. Sometimes you have time, but you don't have ingenuity, right? But some of the solutions that the most ingenious can be very short. Sometimes you don't have time, but you have a lot of brain power. Okay, you guys have any questions?
So what was the original question?
The original question.
I never got to see it.
Oh.
Was it find like the area of that triangle?
No, it's fine.
No, it was find the length of PQ.
Oh yeah, I remember that.
Yes. Actually, I told you that. It wasn't because you were late.
Yeah, I remember that now.
Yeah, it was. See how one always can make excuses for oneself. It's like, okay, very good. Let us move on. So this is a